Hello everyone, myself Hardik Chauhan, roll number 21EC30022. So this is a video regarding the DIY assignment 3 in which I will be showing the disassembly of electric kettle. So this is our electric kettle and it is used for boiling water, boiling eggs and making tea also. And in hostel I have seen some students also use this to make their lunch or dinner. And basically it comes with two main parts. One is for storing the water or anything which you want to boil, and other thing is the below part, the supply part, which will supply electricity. So you can see the both parts are there. The first is its container and the below thing is the supply board. So I will now show you that this electric kettle in working condition. So I will switch on the plug here and and on my electrical kettle from here. So you can see the LED is glowing here and water will take some time to boil. So I have for the water in it, and as you can see, so it is boiling. So as you can see, it's the voice from the kettle, so it is showing the water is boiling. So I will off it. So I have shown you that it is in working condition. So after that I have taken out the water from it so that I can disassemble it now. So let's start. So for this power board, you can see there are three screws are there. So I'm going to open it. So in this container, there are three screws below, and one is there. After opening the lid, there are two screws are also there, and one screw is there in handle there. So I'm opening it now. So this lid can be taken out from here. So you can see there are two screws also there. So now, as you can see, I have disassembled the electric kettle. So now I will show you the different parts of the electric kettle. So, as you can see, it is the base of the, so it is a covering of the power supply base, and it is attached here. So I plugged it out, and you can see there are three wires, and the red wire is live wire. The blue is for neutral wire, and the middle one is for earth wire, and this is for the supply. And as you can see, it is 3-pin plug that is from power supply board, and it is a part the part covering of the handle of the container. and this is the below part of the container, like this. And this is the outer part of the LED, outer part inside which LED is put. And it is the lid of the container. So it is basically of two part. One is this. So basically we can put the lid above this steel part. So both are the same part. That is the opening of the lid of the container. And you can see that there is a mechanism for opening this lid. So most probably there is going to be a spring inside this, the opener, through which when we press this thing come inside. And now, so basically it is the inside part of the switch. So this is the covering of the switch, which is put above it, and this is the inside part. And here it is a switch, so it works as dual thing. It works as switch as well as a thermostat also. So we can also say that this is a thermostat switch. And here also the middle thing is taking supply from the supply board, and also there is a thermostat mechanism. And the white thing which you are seeing is the concealed heating element. So concealed means it is hidden, and heating element is basically made of nichrome. So nichrome is basically 80% nickel and 20% chromium. So this composition is used because it results in pretty much high resistance. So I will explain you later on that why high much resistance is required for this heating element. And I have shown this. And one part also, this is also a part of the supply board. So all these are the different parts. So inside this bowl, inside this container, there are the markings. Here you can see it is written max, and below, and there is something inside it is written minimum. So we are not allowed to put water above this maximum value and not below the minimum value. So I will now. So there is also neon bulb is the visual indicator for showing that the power supply is on and water is boiling and or heating. And this is a neon bulb. So this is used. This is used because it consumes less power and results in and also have long life. So this is the switch. We can press this. Now it's on and now off. It's now on and it's off. So I will show how the electric kettle automatically cut off. So to explain this, I will show you the back part of the switch. So there is a metal coil which change its shape when its temperature changes. So as you can see, if when I on this, but when after some time the temperature of this metal coil increases, so it automatically changes shape and put its shape such that it go backward, like So when it go backwards, the switch automatically cut off, automatically off. When I pressed it, so now I am manually pressing it, but when the temperature is increased, it automatically, the metal coil automatically goes above and ultimately leading to the automatic cutoff. So this so how the automatic cutoff happens? So there is a so this is on and off switch. So one wire of the switch is connected to the thermostat here, and the other and one another wire is connected to the heating element. So if the switch is off, the power supply is cut it off and heating element will no longer getting the power supply or current. So this type of mechanism is also here. This type of metal coil mechanism is also present here in this thermostat. So if somehow if a person try to press it like that this the switch does not switch off, but in that condition also there is a thermostat present here which will ensure the safety and automatically cut off despite of you have pressed here, despite you have switched on the switch here. Now I will tell you that what are the materials used for making this electric kettle. So mostly two materials are used in making this electric kettle, the plastic and the stainless steel. So this container body is made up of stainless steel and this handle is made up of plastic, and the nichrome wires are also used. Nichrome wires are also used, that is 80% nickel and 20% chromium in the heating element. And other than that, all the body parts are of plastic, and this is also stainless steel, the one part of the lid, and but the rest part is plastic also in the lid. All in lid also the other part is plastic. And this is switch covering, and this is power supply covering. So mainly stainless steel and plastic is used, and nichrome wires are also used in this electric kettle. There are two types of electric kettles. One we can say corded electric kettle or cordless, but that doesn't mean that doesn't mean that one does not have cord and what one have without cord, that is cordless. But that basically means is uh, for the cordless electric kettle, there is a separate power supply board which have a cord for the power supply. So, and when it comes for the corded electric kettle, the switch plug is directly connected to the container. So the benefit of this cordless electric kettle is that after the boiling of the water, uh, we can take this electric kettle to anywhere. That is, it is so this means that it is very portable. Okay, so now I will tell you why why the nichrome material is used while making this heating element. So as you can know that in electrical circuits, the heat generated is given by the formula I square R dt for a dt time period. And as you can see, if the nichrome material is used, the resistance is very high. If the resistance is very high, the heat generated is very high. So we want the heat to be more because we are boiling something here. So that's why the nichrome wires are used in this heating element. I have shown you the two thermostats. So now I will tell you the technical definition of the thermostat. So thermostat is a regulation device component which senses the temperature of the physical system and perform the different actions. So different actions can be and cutting of the supply and when required. So okay, so I have told you that this white color thing is the heating element. So the reason for this whitish color is the limescale buildup. So if the water is due to the water, this whitish layer has come, and this is called the limescale. And basically, limescale is a hard and chalky deposit consisting mainly of the calcium carbonate, that is CaCO3. You can also see this LED is connected to the heating elements. This neon LED, neon bulb, is connected to the heating elements, and also so this is from where the main power supply is coming. So when I put it inside it, you can clearly see some pins are coming above. So now there is no contact between this the wires here and the thermostat. So when I press, you can see the two pins are coming up. I think the golden color pins. So this is ensuring the contact between the power supply and the thermostat or the electric kettle, and ultimately leading to the on of this heating element, and after that boiling of the water. So the red wire is connected to the middle circle, and the neutral wire, that is the blue wire, is connecting to the outermost circle, and the middle wire, that is the earth wire, is connecting to this dot. And as taught in thermodynamics, that there is a transfer of heat when there is a transfer of heat from the higher temperature body to the lower temperature body. So that is what this electric kettle is using for the boiling of water, because when the heating element starts heating up, so the temperature difference between the heating element and the water which you have put it inside the container increases. So this temperature difference cause an energy transfer known as heat, and leading to the boiling of the water. So now I am assembling my electric kettle now. So now I have assembled it now, so I will show you that it is in working condition. So as you can see, the LED is glowing, and I have poured the water in it, and water is boiling. So now I will also show you the auto cut-off mode of this electric kettle. So let the water some time to boil. You can see the auto cut-off mode. Now it's see again. I am pressing it.
it is itself getting off. I am pressing it again. So you can see how this auto cutoff mode happens.
That's it. Thank you for watching.